Hello guys, this is going to be a complete explanation of polar coordinates. This type of coordinate is going to be very useful for dynamics, for kinetics, for kinematics, and it has a lot of applications. So we're going to start by having a polar axis and a y-axis. Okay, in the polar axis is where the angle starts. Okay, so we have a trajectory. I mean, it can be any trajectory you want. And we have a particle right here, moving in this trajectory. Now, we draw our radius or our position vector that starts in the origin of these two axes, okay? So we have O, that is the origin, and there our radius start. I mean, this is gonna be like our reference. We're gonna locate all the movement of the particle from this origin, from this reference. So we have this radial vector. Okay, we have the radius as a vector. Now, there are two important vectors in the polar coordinates that are the radial vector and the transverse vector. The radial, as you may suppose, goes at the same direction as the radius, of course. So the radial vector right here. And the transverse vector goes perpendicular to the radial vector, not tangent to the trajectory, okay? You will see now. This is the transverse vector. As you may be thinking, oh, but in normal tangential coordinates, there was one vector that were always tangential to the trajectory, but now it is not. It doesn't matter if it's tangent or not to the trajectory. What matters is the radial goes in the same direction than the radius, and the transverse vector goes always perpendicular to the radial vector and also in the same direction as the growth of the angle theta. So here we have theta that goes clockwise, grows in an anti-clockwise, like this. So the transverse vector grows in the same way, in the same direction. Now, as you see now, we have two super important variables here that are the radius and the angle. And with these two, we're gonna have six important variables that are gonna be useful for our expressions of speed and acceleration. We're gonna have, in terms of radial, we're gonna have radial position. We're gonna have radial speed, and we're gonna have radial acceleration. At the same time, we're gonna have in angular expressions, we're gonna have angular expressions according to the angle theta. Theta position, theta speed, and theta acceleration. Sorry. Remember, when you see one point, when you see one point, it means that is the first derivative of r, so we have speed. And 2 points means the second derivative, so equals acceleration. Now with these 6 variables, we will have a ton of information. Starting with the speed as a vector, it is the same as r point multiplied by the radial vector and r times theta point multiplied by the transverse vector. So this is going to be our speed. This formula applies in any case of polar coordinates, okay? In any case. So it is strong, it is important. Now, we also have, well, I mean, we can express this in this way. We have the radial speed as r point, the radial speed, and we also have the transverse speed that equals r times theta point. Transverse speed. Oh, just to mention, we can express the radial vector as cosine theta sine theta, and the transverse vector as minus sine theta cosine theta, okay? Like if you have a triangle, you know this is cosine, this is sine, and the transverse vector is just the first derivative of the radial vector. Now we continue with acceleration, okay? So we have this long formula, but you will learn it. R 2 points minus r times theta point squared multiplied by the radial vector. And we have 2 times r point theta point plus r multiplied by theta 2 points, and this is going to be the transverse acceleration. So we can express it in this way. Radial acceleration equals r 2 points minus r multiplied by theta point squared. This is radial. According to the two vectors, right? And this is the transverse acceleration. Okay, now we have powerful expressions that apply in any case when we use polar coordinates. That's why this is so useful, because everything is in a formula. We don't have to make any more effort to find the acceleration and the speed. The key thing here is to find these 6, to find all of this. If you have all of these values, then you have the speed and the acceleration automatically. You don't have to do more than it. Well, this is everything. This is all for this video. Now I'm going to solve a lot of problems, and you will see in the following videos. See you later.